Hello everyone. In this video, I will explain my deep learning based stock prediction project based on gold related stocks. The key highlight of this project is a privacy preserving federated learning framework that combines Finbert for sentiment analysis, BiLSTM for time series forecasting, and MML for fast adaptation. I will walk you through data extraction, custom sentiment creation, data preprocessing, model training, accuracy evaluation, and finally, why my proposed model perform better than existing approaches. The project focuses on gold-related stock price prediction. Instead of using only historical prices, we also use financial news sentiment and privacy-preserving federated learning to improve accuracy and security. Let me quickly explain the key technologies. Finbot to extract sentiment from financial news. BiLSTM to capture long-term and short-term price patterns. Federated learning so data never leaves the client systems. ML meta learning to help the model adapt quickly to new market conditions. This makes the system both intelligent and privacy preserving. First, let's talk about data extraction. I used Yahoo Finance YFinance library to fetch the historical stock price data for gold related companies. Using YFinance library allows a easily collect attributes such as close, high, low, open, price and the volume. The data is fetched date-wise and stored into a pandas data frame. This gives us clean structure financial time series dataset, which forms the numerical backbone of the project. Stock prices are heavily influenced by news and market sentiment, so numerical data alone is not enough. To solve this, I created a customer sentiment dataset using financial news headlines related to gold and stock markets. This news texts are processed using Finbert, which is a finance domain specific version of BERT. Finbert classifies each news system into positive, neutral, and negative. Before starting the data preprocessing, let me first explain the main libraries used in the project and why they are required. NumPy and Pandas, used for numerical computation and handling structured financial and sentiment data. Skitlearn, used for data preprocessing, feature scaling, train next splitting and evaluation metrics such as MSE. Matplotlib and Seaborn, used for visualizing stock trends, sentiment distribution and model performance. TensorFlow and Keras, used to build and train deep learning models such as BiLSTM for financial forecasting. PyTorch backend required to run Finbert based transform models. Now let's jump into the data preprocessing. Before training any model, proper data preprocessing is very much important. Here I have handled the missing values using forward fill, convert data to date time set as first date of month, convert volume and percentage column into numeric format, normalize feature using min-max scaling. And here I have applied one node encoding. The proposed model training. Now comes the core of the project, the proposed model. Each client represents a separate gold company name and data never leaves the client side. Locally, each client trains a BiLSTM model using historical stock prices, Finbert sentiment features. These local models are trained using federated learning, where only model weights are shared with the central server. To improve adaptability across the different companies, I integrated ML model, which stands for Model Agnostic Meta Learning, which allows the global model to quickly adapt to new client. using very few updates. The accuracy evaluation of the proposed model. After training, I evaluated the proposed model using standard regression metrics: MSE, mean squared error; RMSE, root mean squared error; mean absolute error, MAE. It is a true bus predicted on global test set. Here is the actual and predicted price. Actual and predicted price using BiLSTM. Prediction residual distribution. Now let's jump into the comparison models and to validate the other performance. I trained multiple baseline models. To validate the performance, I trained multiple baseline models. I have used ANN, LSTM, BiLSTM using plus Finbert and SVM. When comparing all models using MSE, RMSE, here actual was predicted in BiLSTM, prediction residual distribution. Here is the ANN model. Here is a BiLSTM model. Train the BiLSTM framework model performance. It is the SVM model performance, the MSE, RMSE, MAE and MAPE. Here is the model performance ranking based on MAPE. When comparing all models using MSE, RMSE and MAE, a traditional model like SVM performs poorly on sequential data. Deep learning model performs better. Sentiment augmented model further improves the accuracy. My proposed federated model achieved the lowest and overall error. Why MSE of my model is preferable? MSE is especially important in financial forecast because it penalizes large prediction error heavily. A lower MSE means fewer extreme mistakes, more stable prediction, higher reliability for real-world trading and analysis. Since my model achieved the lowest MSE among all compared models, it proves that the predictions are both accurate and robust. Conclusion. Now let's jump into the conclusion. This shows that combining sentiment analysis, deep learning and federated optimization can significantly improve stock price prediction while also protecting data privacy. In the future, this approach can be extended to real-time trading systems, multi-stock prediction and large-scale financial platform. Thank you for watching.